Okay, here's how I recommend thinking through these calculations so you don't have to keep reaching for a calculator and punching a lot of buttons. You will need to punch the buttons, okay, to get an accurate result, and of course we're talking about a very precise condition here, but we're going to do this symbolically. We're not going to do it numerically, but still for practice, it's good to get the numbers and understand what kind of numbers you have, right? So order of magnitude. Order of magnitude calculation is going to be what? Like 10 to the negative 33rd, that's only about 2/3 of that, right? Divided by the momentum, which is mass times velocity, which is 10 to the negative 30th. And that's multiplied by your velocity, which is 10 to the 6th, and that's going to be in meters, and it's easy to calculate that. And of course you want to do your unit calculation, maybe within here, maybe off to the side. But yeah, it's clear that if you take joules times seconds, a joule is a kilogram meter squared per second squared, so that's a kilogram meter squared per second. And this is a kilogram meter per second, and it's going to leave you a meter. Okay? And that's about what? That's 10 to the negative 24th, 10 to the negative 33rd. So that's going to be around 10 to the negative 9th meters, a nanometer. So if we refine this, we're going to have 2/3 of this because of that's about 2/3 of this, right? And this is actually a 9 times 10 to the negative 31st, so it's going to be about 10% bigger because of this. Okay? 10% bigger than 2/3 is about almost 3/4. So I'm going to say that's going to be approximately, I'm guessing 7.3 times 10 to the negative 10th meters, 10.3 angstroms. Okay? So, yeah, if you can learn to do these kinds of calculations, it saves a lot of button punching and allows you to think about it rather than punch buttons. Okay? So I recommend that if you're able to develop that little bit of mental arithmetic and proportionality thinking, it's worth it. Okay? So there's your approximate wavelength, right? Okay. Now let's use the symbols. So in symbols, well, we're going to do it in terms of the symbol H, and we're going to do it in terms of the symbol M sub E, right? But V has been expressed in symbols, so we simply write down this expression, and then we can start manipulating things and start understanding what it takes to match up an orbit with the wavelength of the electron. Because it's going to turn out that this wavelength is no good at all when you have a circumference of 6.3 times 10 to the negative 10th meters. That wavelength does not match that circumference, and no multiple of this wavelength will match that circumference, right? Okay? Or no integer fraction of that wavelength, because half that wavelength, well, it's not going to work. Okay? So, you're out of luck. In other words, you're not going to get an electron orbiting at that distance. Okay? Because this is the speed at that distance. Well, if you use the speed at that distance and the radius, that's the way it works out. So you want to understand that, but let's go ahead and do the symbols now and see how we can match things up.